This is chapter 16, lesson 1. This was the warm-up for today. I recommend that you pause the video at this point and have a try at answering these questions. Now, the idea with this one is you should recognize that the gradient is dy by dx, and the original equation is going to be y. That's the original function. So what we're actually trying to do is think of something that when you differentiate it, gives you 2x. Now, you should figure out for that one that it's x squared, and you can try if you differentiate x squared, you do indeed get 2x. For 3, that's just going to be 3x. And then with a little bit of experimentation for this, you should be able to figure out this is 10x cubed. Now, then we get to question 2, and he says we've got to come up with 5 equations. Now, I think most people come up with x to the 5 pretty quickly, but then they get confused. They think, what else can we differentiate that gives us 5x to the 4? So, obviously it's got to be something to do with x to the 5, but really it's figuring out what do we differentiate that gives us 0? And that would be just a number. So if we had like x to the 5 plus 1, or we could have x to the 5 plus 2, in fact you could have minus 1, you could have minus 2, then actually it's fairly easy to come up with 5 equations. And in fact you could come up with an infinite number of equations. As long as it has x to the 5 and then some number on the end, then that's going to work perfectly. Now what's actually happened here is, when we differentiate, we take an expression and then we work out from here to here, and then from here to here. What we actually did in the warm-up was we did the opposite. We took our answer and tried to figure out what the question is. Now when that happens, that's called integrate, or the topic specifically is integration. So the reverse process of differentiation is called integration. To show that we're going to do an integration question, we're going to use this little symbol here, which is called the integration symbol, or we can say it as the integral of, and then whatever the expression is going to be. Now the S, this actually looks like an S, and that's because actually we're working out a sum here. We're going to talk more about that in the next lesson. So the integral of 2x dx, so we put dx on the end of a question, sort of to show that it's like we've differentiated something that has an x in it, and we've got 2x. What is the original question? So it's called an indefinite integral, as there are several possible answers. Like you saw in the very last one, it could be like plus 1 on the end, plus 2, minus 1, minus 2. We don't exactly know what it's going to be. Now actually we get around that problem by putting plus c at the end of the question. So we work out the integral for 2x, which was x squared, and then to show that it could be plus 1, plus 2, plus 3, something like that, then we put either plus c or we put plus k on the end of the question.